ladies and gentlemen.
So let's talk equations of circles. So we've explored a lot of different aspects of circles in the last video. This video is more specifically about the algebraic representation for the equation that represents all of the points on the edge of a circle that are a fixed distance from the center. So how we do that is actually with Pythagorean theorem. If you were to picture a right triangle where one of its vertices is fixed at the center, in this case we're going to fix it at 0, 0, the origin, then for any point on the circle we could draw a right triangle where one of the sides is touching the x-axis, and we can draw a triangle kind of like this. So I could also draw it in this corner over here, and it would look something like this, and this point here would be x comma y still. This would still be r, this would still be x, and this would still be y, and we can use Pythagorean theorem. So it doesn't matter where we are on the circle, we can actually just use Pythagorean theorem in order to figure out the equation. So that is where we get the x squared plus the y squared is equal to the r squared for a circle centered at the origin specifically. So let's try it out. Given an equation of a circle, x squared plus y squared equals 25, what is the radius? Well, we are going to look at the number by itself. We have 25, so r squared is equal to 25. So r is equal to the square root of 25, or just 5. Really not that bad. Now let's shift where the center of the circle is. So if we shift the center of the circle, instead of being 0, 0, it's now this h comma k, we get a new equation, y. Well, this distance now, this bottom edge here, is whatever the x value is, taking away whatever the x value of the center would be. So if this is h and this is x, this distance would be x minus h. We can do the same thing for y. If this is k and then this is y, the distance would be y minus k. And this r is going to stay exactly the same. So that is where we get this equation from, and that's why it's subtraction as well. We are subtracting those distances. We would end up doing some addition if we were in the negatives, because subtracting a negative is positive. So if you see a plus in here, it means that it is on the negative side of whatever that axis we're talking about. So let's try some things out. So first and foremost, let's find the center and radius of a circle that is x minus 3 squared plus y plus 6 squared equals 81. First and foremost, we know that this equals r squared, so 81 is equal to r squared. So r is equal to its square root, or 9. So the radius is 9. The center is going to use these values here, but the opposite. So instead of minus 3, we're going to have a center at the x value of positive 3, and instead of plus 6, we're going to have a y value of minus 6. So the center of this circle is 3 comma negative 6, and the radius is 9. Not too bad. Now let's actually write an equation. So let's write the equation of a circle with a center 4 comma negative 7 that passes through the point 2 comma 1. The normal circle formula is x minus h squared plus y minus k squared equals r squared. Well, we have h comma k. We also have a point that should represent x and y. So if we plug these in, we should end up with r squared. So we have 2 take away 4 squared plus 1 take away negative 7 squared is equal to r squared. 2 minus 4 is negative 2. Negative 2 squared is 4. Then we have 1 minus negative 7, which is positive 8. That squared is 64. Adding those together, we get 68. So r squared is 68, and it did not ask us what the radius would be. The radius would technically be the square root of 68, but we can just leave that as is because that is r squared. So our equation is going to be x minus 4 squared plus y minus negative 7, which would be plus 7 squared, is equal to 68. We don't have to put the square root of 68 squared. We can just leave it as 68 since that is r squared. Not too bad. Now let's try something challenging. We have an equation for a circle that is not written the exact same way. Remember that we are used to these as x minus h squared plus y minus k squared is equal to r squared. This has that distributed out. So how does that look? Well, let's distribute these out and see what happens. If I double distribute this out, I'm left with x squared minus 2hx plus h squared plus y squared minus 2ky minus plus k squared is equal to r. So we need to make sure we can figure this out. So whatever's attached to the x is 2 times larger than whatever we need h to be. And whatever's times by y is 2 times what we need the k to be. So if I look here, it looks like h in this case is going to be a positive 1, because remember it's minus here. So h is going to be 1 and k is going to be 5. So now that we figured this out, we know that it's going to be x minus 1 squared plus a negative 5. Y plus 5 squared is equal to r squared. Now we need to figure out what's going on here. Well, we can see that we'd be positive h squared and positive k squared on the left. So we would actually have to move these over via subtraction. So what we are left with over here, this negative 10, actually represents r minus h squared minus k squared. So we know what h is. H is 1. So this would be 1 squared, or 1. K is negative 5. Negative 5 squared is 25. So we are left with, negative 10 is equal to the radius minus 1 minus 25. I just noticed I made a mistake. These are supposed to be squared. You're probably yelling at me. It's fine, it's fine. So negative 1 and negative 25 make negative 26. So the radius squared minus 26 is equal to negative 10. Add 26 to both sides. We're left with 16 is equal to r squared. So r is equal to 4. Meaning our final equation is x minus 1 squared plus y plus 5 squared is equal to 4 squared, or we could just leave it as 16. And that is our final answer. So a little bit of work in the last one, but if you understand the equation, where the equation comes from, and how to manipulate equations, you can find out what you need. If you have any questions about anything, please let me know. Otherwise, I look forward to seeing you in the next video.